Have you ever wondered how to build a robot arm that can do things? In today's fascinating journey, we're diving into the world of robotics. We're going to break down the process of building a robot arm into simple, manageable steps. You might be surprised to find that the materials needed are more accessible than you think. Whether for a school project or just for fun, this skill opens up a world of possibilities. By the end of this video, you'll know exactly how to build your very own robot arm. To kick things off, gather all the necessary materials. Building a robot arm is like a puzzle, and we're about to collect all the pieces required. First in line are the mechanical parts. These are the bones and muscles of our robot arm. Servos, which are little motors that control movement, are crucial. Microcontrollers, the brains of our robot, are also essential. We'll need a bunch of metal brackets too. These are the skeleton that gives our robot arm its structure and strength. Next, let's talk tools. A trusty screwdriver is a must-have for any robotics project. It's like a magic wand, connecting pieces and making things happen. Soldering irons are also required. They're the glue that binds our robot's electronic components together. Remember, every piece matters. Each part plays a significant role in making our robot arm move and function. Once you've gathered all your materials, you're ready to start building. The first step in building your robot arm is assembling the base. Now this is where your robot arm will find its footing. Imagine it like the roots of a tree, providing stability and support. Let's get started. You'll need to connect the base parts together using screws and brackets. Begin by aligning the holes on the base parts. Then, take your screws and carefully insert them into the holes. Use a screwdriver to tighten them up. Keep going until all parts are securely connected. Next, attach the brackets. They're like the secret ingredient to a sturdy base. They'll provide additional support and keep everything in place. Just like with the base parts, align the holes on the brackets with those on the base, insert your screws, and tighten them up. Remember, a sturdy base is crucial. It's the foundation that will allow your robot arm to move and function without toppling over. With your base assembled, you're ready to move on to the arm. Now it's time to assemble the arm of your robot. Imagine the arm as the backbone of your robot, a vital component that will perform the actions and tasks. First off, we're going to connect the servos, the essence of movement, to the base. Think of these servos as the muscles of your robot arm, providing the power and precision for every motion. Next, we're going to attach the arm segments. These segments are like the bones, providing structure and support. It's crucial to ensure they align perfectly, as this can significantly impact the arm's range of movement and functionality. As we connect each segment, we're building the robot's reach, its ability to interact with the world. Each segment you add extends the arm's capabilities, just like adding links to a chain. Finally, we're going to install the gripper at the end of the arm. This is the hand of your robot, the part that will interact directly with objects. It's designed to grasp, hold, and release items with precision and care. Each part of this assembly has a specific role, contributing to the overall function of the robot arm. From the power of the servos, the structure of the segments, to the finesse of the gripper, every component plays a part in bringing your robot arm to life. With the arm assembled, you're almost done. There's just one step left. The final step is programming your robot arm. At the heart of our mechanical marvel is the microcontroller, a mini computer that directs the arm's movements. This tiny titan interprets the commands we give it, sending signals to the motors that make our arm move. Now let's dive into the programming part. You'll need to input a series of commands like a choreographed dance routine that tells the robot arm exactly what to do. Think of it as teaching your arm its ABCs. For instance, to make it lift or turn, you'd instruct the microcontroller to send a specific signal to the relevant motor. Remember, it's all about trial and error. Don't be disheartened if your arm doesn't dance perfectly the first time. Tweak your commands, test, and tweak again until you've got it just right. And voila, you've built and programmed your very own robot arm. Now go out there and make it do things.